deal with this right now, I'll deal with it tomorrow or another day, but at some point it does
Um,
have to be addressed.
yeah, I agree. I was wondering, if we could just work on some physical science today, like what we were working on Monday, and then we'll go check this out with this essay.
That's fine. The sooner that something is done here, the better. You can see, like a 9 hour delay in her responding to you. Um, you know,
Yeah.
but you may find that this is going to be the theme through this course is there's going to be a lot of pushback from the instructor. So, okay, physical science, right, awaiting feedback. Okay, so it looks like you submitted something here for lesson 10.
Yes.
Okay. Right. Oh,
Just
it's
from what,
awaiting. It's awaiting feedback means they have not
yes.
given you feedback. Okay. All right. I didn't know if that was yours. All right. I mean, the good news is here's your head of this.
Hmm.
If mom or dad are wondering how you're doing, I think that's a good sort of indicator. You can also mention that, hey, there's other assignments that are done. We're just waiting to get waiting to be able to submit them. So, all right. Well, last time we started working on 12, lesson 12. Does that sound right to you?
Yeah.
Okay. Free fall. This was unfortunately yet another lab.
I think we skipped lesson, no, we were working on lesson 12 last time, just like whatever we could do.
Yeah, I'm looking at it now. Okay. So let me go share that. All right. So we answered question 1, question 2, question 3, and we got to question 4. You answered that question. Okay. All right. So we are up to question 5. What is the direction of our object's velocity? Okay. Um, all right. So uh, let me go to the internet to see if I can find something that helps with this. There's this discussion of the difference between vectors and scalars in physics, and we'll try to. Don't even know if that's a good one. Yeah, this is probably better. So I'm gonna grab a picture here, nip it in, so we can talk about the difference between scalars and vectors. All right, so scalar quantities have a magnitude but no direction. They're like a distant, like a number. You can think of them as a number only. So you can think of distance, speed, mass, energy, density, power. These are all numbers. They're just numerical values. Okay.
Got it.
Vectors have a direction. So it's like you might a lot of times people use speed and velocity interchangeably, and they're not. Velocity is the direction that you're traveling. You are traveling at a speed, but it's in the direction that you're traveling.
Hmm.
Same with some of these other ones here, like mass and weight are often um, used interchangeably, and they're not really correct, but it doesn't really matter. There's a direction uh, of the force that is being applied. You'll see that down here. Weight is actually a force and other things. So there's this discussion here about that. Um, Now, when you drop an object,
Okay.
the velocity vector is always pointing down. And let me see if I can find maybe some animation, velocity vector, falling object. Okay, this is way too technical, but it's got the right arrows pointing in the right direction. So I'll snip it in here. All right, so when you drop an object, this V that's in blue, you can see that it's always pointing down. Maybe you see that, maybe not.
Yeah, I can see
Okay.
that.
So without really understanding this, the reason it goes down is because the velocity is always pointing down.
Hmm.
So, okay, so the answer to this question is what is the direction of an object's velocity? It's always pointing down. So could you put that into a sentence for us?
All right. So, can I say like when dropping an object, the velocity is always like pointing downwards or something like that, or should I just say
Exactly,
just pointing
exactly.
down?
Yeah, exactly. Yes, that's perfect.
Okay, cool. So should I write that still
Yes.
or okay.
Yes, you
Okay.
got it right. I'm only suggesting a few things there to write.
Got it, got it. All right, there we go.
we're just going to add in that word vector. That's important.
Oh yeah. Where would I put vector though in my sentence? The velocity vector is always pointing downward.
Exactly.
Okay,
Okay.
cool.
So the next couple of questions here. All right. It says, given your current understanding of free fall, so have you fallen from, I don't know, like a diving board on this trip or jumped into from the side of a pool?
I once like jumped into the ocean from a water trampoline, but that was like when I was really little. I've done
Okay.
so yeah.
That's actually the best example. There's this sort of moment where you feel sort of suspended in the air. Um, Maybe you feel that way on the ice. I don't know how high you can jump. Um,
I don't even know either, and I've been skating for 3 years.
yeah. Um, you sometimes get this feeling when you jump off of a high place. Now, this question is asking uh, the difference between dropping a coin and a piece of paper. Do you have a piece of paper near you that you could drop?
Uh, right
That you,
now, no, but I do know that when I used to do this when I would like hold a piece of paper up, and when I dropped it, it would like float around for a little bit before hitting the floor.
that's right. And a coin or something small like that, like keys or I don't know.
Yeah,
What-
when I drop when I've dropped in so many things. When dropping a coin, it hits the floor and then it spins for a little bit before
so
laying
just focus on
flat.
the yeah, just focus on the hitting like the time from when you drop it to when it hits the ground. Um, what what's the difference? I mean, visually, if you could, we would there the idea is you would do this, but visually, what's the difference?
The difference is that I actually don't know. Like
Well, you just described it. You said the paper kind of floats around, but what would a coin do?
a coin would spin.
No, when it falls, just when it falls.
Oh,
It doesn't really spin while it's falling.
well,
Maybe
when
a
it's
little, but
falling, it does. It's like hold on, let me think. Oh, it's like up on its side. Like it's how do I describe it? Like um, it's like wait, when a coin is dropping, it's like on it's flat, and then when it hits the ground, it starts to spin.
forget what you gotta. You can't emphasize the nothing on when it hits the ground. Just from the time you drop it um to when it hits the ground. Like what do you see?
Got it.
Like I got. All right, so I can't find. There was a video I looked at a long time ago that was really kind of neat. So what I'm trying to get you to say, and I was gonna have you find something else to drop, but it just it has what's called free fall, like it just
Mm-hmm.
straight down. Like there's no waviness, there's no resistance, it just falls, um, straight down. The paper, on the other hand, it sort of like you said, it floats in the air. I call it like a
Yeah,
waving motion. It sort of goes back and forth. And then it also sort of gently hits the ground, whereas the coin is more like a boom, right? Something
right.
more like that. So, um, the reason for this is air resistance. Okay. and
Okay.
they they actually have this really cool video. Actually, now let me see if I can find it now that I know what I'm searching for. This might be worth watching. They have a feather bowling ball in a vacuum. Um, and if you were to guess what would hit the ground first, a feather or a bowling ball?
The bowling ball.
That's right. And that's
Because the
because
bo
there's air resistance. Now, this is a 1 minute video. I think it's worth watching if you don't mind. You want to just quickly look at it.
yeah,
Um,
I want to see it. I will check it out. Let me just mute myself first. Okay, I just finished watching the video, and I like the fact that they also showed how without like the what's it called, the air motion, the feather drops at the same time as like the bowling ball, like without floating around and stuff.
right. And that's exactly what we're describing here, which is that the the bowling ball and the feather actually hit at the same time. It's kind of amazing, right? Like you wouldn't think that, but it does.
Yeah.
So, but that's not the answer to this question, but that's the reason the paper floats and the coin just goes straight down, falls, is because there is air resistance. Um, so you wanna write a sentence or two that says that like basically they're trying to ask you like which will hit the ground faster, um, the coin or the paper, and why.
So basically, they're just asking for which will fall faster, the coin or the paper. I know which one.
Um, well, you said it. The paper kind of floats around and the coin just drops.
Yeah.
So
Because
which
not to mention that the coin is also heavier.
so the bowling ball and the feather, that example is supposed to illustrate that, hey, like it actually doesn't matter. Mass doesn't matter, but like it does, but it doesn't, right? It depends if there's air resistance or not.
Right. Here's what I wrote. I don't know if that sounds okay. Maybe I should just
Because this is not your best effort as far as writing a sentence.
yeah.
Let's see if you can do a little better here. So remember when you're answering a question, you can always reuse the words in the question. So the
Uh,
coin will what faster? What will it do
oh,
faster?
okay, got it. Is this a little bit better?
Yeah, grab it here. Take a look here. Okay, so okay, the coin will hit the ground faster. See how in the question says hit the ground faster? You want to reuse
Uh,
that word. The coin will hit the ground faster, um, because it is a straight free fall. Uh, and then you can say from the time it is dropped. Okay. When dropping a piece of paper, it floats in the air for a while before gently hitting the ground. Okay. Now, why don't you add a sentence here about the mass of the coin versus the paper, or you know the shape? Like the coin is very small. The paper has more sort of surface area.
all right. Um, so you mentioned with the surface area, like what exactly should I say? Because I had a
Which
thought and
has
then I
more
forgot.
surface area, the paper or the coin? Or the coin?
The coin, I
No,
think.
no. The surface area is literal area. Like if you put a coin on a piece of paper, the coin is much smaller than the paper
Oh, okay.
in
The paper
size.
has more surface area.
Yeah.
All right. So I just wrote a sentence saying the paper has more surface area than the coin. Is that good or should I add more?
Why is that important though? Like that's the like that. Yes, that's true, but why is that important? Is you're trying to answer the question of which will hit the ground faster and why. I mean, you've sort of addressed that here. Um, I was initially suggesting you talk about the mass of the object.
Okay.
Like, what is the difference in the mass of a coin and a piece of paper, and why does that matter? Like you
All
said,
right.
you've dropped stuff before. So what is the sound that it makes when you drop something?
Um, so I'm just gonna use the paper and coin. When I drop a coin, it makes a little like a ding, like
Right,
a
but I'm thinking something bigger, like you drop your phone, you drop your skates, you drop, you know,
oh, I've
whatever,
dropped my
suitcase.
phone a lot.
Right. And
It
it
makes
makes
a
a pretty
sound.
makes a loud sound. But if you drop a piece of paper, like nobody really notices.
Yeah,
And that like that should resonate with you, like, oh, like dropping a heavier object like a coin is is more um uh, forceful, than say just a piece of paper.
you got it. Wasn't like a good example of like the sound it makes when a heavier object is being dropped, like a thud, like when you hit your cell phone, like accidentally you bump into a wall and stuff.
Yeah, but
Like this
we're
is
I'm only trying to refer to the sound so that you have a distinction between the two. Um, like it really would be better if you were to drop a coin or a book or whatever's in that space you're in and a piece of paper to see the difference. Like somehow you're not visualizing like what the a drastic difference is and then why it's different. And it has to do with the mass of the object or the surface area. Like you can go either direction on that, but the mass is probably the more intuitive one for you.
mm-hmm. All right, here's what I wrote. I just changed up some of my words, and so that's why it took so long.
Yeah, this is much better. This is more complete here. All right, so that definitely answers that. All right, so now the next question here, and um it says, given your current understanding of free fall, what do you think will happen? What do you think the difference will be between a coin from different heights? I tend to think of coins aren't, book like dropping a book from, say, waist level, and then a book from, standing on top of a ladder, or, really, this is like the jumping into the pool, sort of falling in versus going off a diving board. Um, what's the difference to you? Basically, they're asking how does height impact the free fall? And you should think about things like speed. We've talked about sound, force, stuff like that. What do you think? I mean, what kind of stands out to you when you?
Um, when I- so I'm gonna say when you're dropping like something heavier from a little bit, like when you're at a high, like let's say we're at a library, right? And we're trying to find a book on a high shelf and we accidentally drop it, it makes a louder sound than it does at a lower shelf.
Right?
It's like the higher you get and you drop something, the louder the sound's gonna be. But if you're dropping something like there's no sound at all.
Okay.
So,
Now how about the force? The force that you hit the ground or the water or the ice.
ooh. I can talk about ice. I once fallen forward. I wasn't even jumping or anything. I just fallen forward because I hit it's called a toe pick on my skates on the ice, and I hit my knee really badly. And I didn't even do anything, but I'm not gonna count that because there was a thud, but it wasn't a loud thud at all.
Yeah, I mean, let's be a little bit more positive here. Like we're talking about, we're trying to talk about, what is something that, like, where and I guess I'm trying to keep going back to the pool, but
No, keep
what
going
is
with
it?
the pool. It's fine.
What's the difference when you hit the water, when you sort of fall in versus, going off a diving board, or if you can remember back to the trampoline on the lake.
Well, I feel like when you fall into a pool, it makes more of a slap sound than a splash because you didn't expect it, and especially if the fall is a belly flop.
Okay, yeah, we're still, so yeah, I mean, I know that's how most people fall in. I'm trying to because we don't normally do this, but like if you were to get on a chair and jump down onto the ground versus getting on top of a ladder and jumping down to the ground, what would the difference be in terms of the force that you would hit the ground?
So if we jumped off a chair, it would make just a little bit of a quiet thud. And then I did not hear what you said for the second option. Did you say a diving board?
Get get on a ladder, 10-foot
Oh,
ladder, and jump off it, hit the ground. Which is going to be more forceful when you hit the ground?
the ladder,
Yeah. So
because there
that's
will be
that's what they're
broken
trying,
bones.
potentially, yeah. So that's what they're trying to get you to say here is that the higher you jump from, the more
The higher
speed
you
you'll hit
jump,
the
the
ground at.
bigger the impact.
Exactly. Exactly. So they're looking for something like that here. Um, so could you try to put a few sentences together that conveys that?
I think when you're jumping off a higher like platform, I think the speed will be the same. No, wait, no, I won't. The speed will be a little bit faster.
Should be faster when you the higher you jump.
Because that's how it works. Okay, here's what I wrote. I just wrote one sentence, but because I can, but I think that's okay.
Okay, so relate that back to a coin. So we're talking about, we use the example of a human because that's more, you really can't see, it's harder to see in a coin. So rewrite your sentence now in terms of a coin, which is it's the same idea. The higher the coin falls, the greater the impact it will be.
I think when I drop, if we were to drop a coin from a very high building, I think I don't know what the sound will be. Yeah, the sound will be like.
Well, don't worry about the sound. I'm just asking you to rewrite the sentence you have here instead of the higher you jump, because again, it can't be first person. You have to say the you have to talk about the coin. The higher and
You
they
drop.
even say it here, the distance, different heights. You can even reuse those words, coin from different heights in your answer.
Right, there we go.
Take a look here. All right, yeah, that's a lot better. That's a lot better. Okay, very good. Okay. So that, believe it or not, is all of the like stuff you have to do before the lab starts. The rest of it is on you to do. Now, we'll talk about the procedure. There's two procedures that we're going to look at. Um, and if you recall, you have to write the procedure in your own words. So we'll definitely talk about that next. We probably don't have time to do that now, but there's basically two procedures that we're going to rewrite, and then the rest of it is up to you to do at some point. So
Got it.
let's pause here and pick up in a little more than 10 minutes, and I'll see you in a little bit.
All right. See you in a
Thank
little
you.
bit.
Okay, bye.
Thank you.